Okay, good morning. Welcome to
Math number 885.
Math885. Get you in there a little bit better. Okay, so I gave you, yesterday we looked at the shape that is on your left, right?
Yeah.
Okay, so what was the shape? So tell us about it and spin it around a little bit.
So first we made a cube octahedron, which
Okay.
is in green here.
Yeah, that's the green one.
Then we tried to make the dual of it by connecting up the center of all the faces, and while they aren't exactly in the center, we got a rhombic dodecahedron.
Okay, we got a rhombic dodecahedron. And then during that discussion, I actually don't remember exactly how it came up. There was a question about finding the volume of either the cube octahedron or the rhombic dodecahedron. So I gave you a challenge this morning, since I was out this morning, to figure out the volume of the rhombic dodecahedron and see if you could find what that was. And you've built two other shapes. So why don't we move yesterday's shape out of the way? And then you can bring those shapes to the center, and then I'll maybe zoom in on those a little bit. And you can explain what they are.
So first I made a rhombic dodecahedron
Okay.
out of double length yellows.
All right.
So first what I noticed was, well, I knew that the rhombic dodecahedron and a cube were related, and somehow I knew that somehow you could make a cube inside.
Mm-hmm.
So that's what I did here on the first shape. So I connected up these vertices
Okay.
to make a cube. So then I noticed that the rhombic dodecahedron is a cube plus these 6 kind of pyramids pointing out of it.
Okay.
What I did for the second shape was I made this shape, but I turned all of the pyramids inside.
Ooh, nice. Spin that around so it shows up on the.
So it's one
on camera.
pyramid per side. So now we have the original cube inside, and then we have the 6 pyramids that equals another cube. So we have the volume of 2 cubes inside the rhombic dodecahedron.
Okay. The volume of 2 cubes. So when you have a double length yellow rhombic dodecahedron, what's the volume of that?
So it's this length 2 blues, and then cubed times 2.
Okay, so it's double a cube. So if we go back to the shape that we had yesterday, bring that back to the middle here, and get your other shapes out of the way and bring that one in. All right, so what's the volume of this rhombic dodecahedron going to
Well, since this is a 3 length, so it's going to be 3 blue length times 2 cubed.
be? Okay. Yeah.
Times 3 cubed and then times 2.
That's right. Right. So we would be able to find in this rhombic dodecahedron, in this one we have here, we'd be able to find a cube whose side length was 3 blues.
Yep.
And then its volume would be double that. Pretty cool. That was great work. How difficult was that this morning to do, since I was actually gone while you were doing this?
It wasn't that hard.
Wasn't that hard?
Fun.
So what made you, how did you bring your other one back? How did you find that cube in there? What did you do?
So first, let's see, I stood it up on this edge, and then I noticed this bottom part was like symmetrical on the bottom.
Uh-huh.
Then I sort of noticed it was a square on the bottom. I connected that up, and then I noticed these could come up, and then there could be a face on the top too. So that was the cube.
Cool. All right. Hey, great work. That's a really good job. Nicely done.